Today we're going to look at reaction stoichiometry. There's going to be a lot of words here, but you can kind of read through this. But basically what you're going to be doing is you're going to be determining the quantity of one substance in a reaction, if another substance quantity is known. So it could be, you know, the quantity of a reactant. You can figure out the quantity of the other reactant that you would need to react with, or you can figure out how much product you might make from a certain amount of reactant. So there's different varieties of these. The first thing you have to do when you do a reaction stoichiometry problem is you have to write a balanced equation. So that's what we spent some time doing before. And then you are going to take whatever information you're given initially, convert that into moles if it's not already in moles. Then you'll use what's called a mole ratio. The mole ratio is going to be the relationship between the moles of the one substance that you started with and the moles or coefficient of the substance you're looking for. So we'll look at some of those as we go. And then once you get to the substance you're trying to determine information about, or the one you're interested in, then you can convert that into either mass, volume, or particle number. So we're going to kind of do this step by step. So the first thing we're going to do basically is determine mole ratios. So here we have a balanced equation that you've already seen. So this is our nitrogen reacting with hydrogen to produce ammonia. And it's telling us that we want to know how many moles of hydrogen, so we're looking for X moles of hydrogen, are going to be needed to completely react with 2 moles of nitrogen. So you're going to start off with your 2 moles of nitrogen. And since it's already in moles, we have a relationship between moles of nitrogen and moles of hydrogen by looking at our coefficients. So remember, there would be a 1 here, there's a 3 here. So what that's telling us is that 2 moles of nitrogen can react with 3 moles of hydrogen. That's going to be our mole ratio, or our conversion factor. So now what we want to do, we want to put our 1 mole of nitrogen down here so that moles of nitrogen can cancel. Put our 3 moles of hydrogen up here so you're in the substance you're interested in. And then now all we have to do is multiply. So that's going to give us 6 moles of hydrogen. This right here is our mole ratio step. And what it allows us to do is it allows us to go from the moles of what you start with to the moles of what you're looking for. To get these, you have to have your balanced equation, and then these numbers, 1 and the 3, come from the coefficients of that balanced equation. So let's look at another one. This one says how many moles of oxygen, so here's my oxygen, so I'm looking for X moles of oxygen, are necessary to completely react with 4 moles of propane. So these just happen to be reactants, but I could have asked you for how many moles of carbon dioxide would be formed or something like that. All right, so, so we have 4 moles of our propane. My relationship between propane and oxygen is a 1 mole ratio to a 5 mole ratio of oxygen. So since they're already in moles, we can go ahead and cancel. So I'd have my 1 mole then of my propane here to my 5 moles of my oxygen here. Moles of propane cancel out. I'll be left in moles of oxygen. 5 times 4 gives me 20. So I have 20 moles of oxygen. So let's say I had, if I was doing a different problem, let's say that I had 3 moles of oxygen, and I want to find out how many moles of carbon dioxide you would form. You can still do that even though they're on opposite sides of the equation, because I still have a relationship of 5 moles of oxygen produce 3 moles of carbon dioxide. So I'm still going to have a mole ratio. So I'm going to start off with my 3 moles of oxygen. I'll put my 5 moles of oxygen down here, my 3 moles of CO2 up here. The moles will cancel, so I'd have 9 on the top divided by 5, and of course you can divide that on out to get the moles of carbon dioxide you would have. So those are just looking at the mole ratio if you start off with moles. The more common types of problems you're going to have are called mass-mass problems, where you start off with the grams of one substance and you look for the grams of another substance in a reaction. So it says how many grams of hydrogen are necessary to completely react with 50 grams of nitrogen to produce ammonia. So the first thing I've got to do is write a balanced equation. So I've got hydrogen reacting with nitrogen to produce ammonia. So this should be a reaction that we're already familiar with. So we need to go ahead and balance this out. So again, if you need to go through the steps to balance, do that. If not, you can just go ahead and write down the coefficients. So now once I get my coefficients, the next thing I'm going to do, I have 50 grams of nitrogen. And I want to find out how many grams of hydrogen are going to be needed to react with those 50 grams. So I'm going to start off with my 50 grams of nitrogen. Now this is where the steps are going to be important. So if I start off with mass, the first thing I've got to do is go to moles. Because remember, the only relationship I have in a balanced equation is my mole ratio between the coefficients of the two substances I'm interested in. So whatever I'm given, whatever substance they give me information about, if it is not in moles, I have to put it in moles. So that's the first thing I'm going to do. So I take my grams. So we did some of this already before in part 1. We know that we have 50 grams of nitrogen. We know that in 1 mole of nitrogen, it's equal to its gram formula mass. So I'd have 2 times the 14. I'm getting 14 off the periodic table would be 28. So that would go here. That's going to get rid of the gram unit, right? And now I'll be in moles of nitrogen. Once I'm into moles of nitrogen, then the next thing I'm going to do is I can use my mole ratio. So this is kind of where we started with the problems at the very beginning. If we started off with moles of something and we want to go to moles of something else. So I have 1 mole of nitrogen. I'm getting this from my balanced equation. And it's going to 3 moles of hydrogen. This is my mole ratio step. So my first step was taking my grams to moles. Oops. My second step is going to be taking my moles to moles, or my mole ratio. The mole ratio is usually the middle step. And then finally my third step in this case is I was going to be taking the moles of my new substance, in this case my hydrogen, to grams. So we've done these end steps before when we start off with one substance and we went to moles of that one substance. So you're doing the same thing you did earlier. Now we're just combining everything that we've been learning. So the moles of nitrogen will cancel. So the rest is just going to be doing the math. So I'd have, and I don't have my calculator right here, so I have 150 would be on the top, divided by the 28, and whatever that is, it's going to give you that many, I'm sorry, that's moles of hydrogen. All right, so I need to do one more step. I forgot my third step. So let me come back and start over on that. All right, so once I get to the moles of hydrogen, then the next step is going to be getting my moles of hydrogen. So I know 1 mole of hydrogen is going to be equal to its gram formula mass. So each hydrogen is 1, but I have 2 of them, so it'll be 2 grams up here. Moles of hydrogen cancel, so grams of nitrogen cancel, moles of nitrogen cancel, moles of hydrogen cancel. I'll be left with grams of hydrogen, and now the rest is just doing the math. So I'm going to run and get my calculator, so hang on just a minute. All right, just to finish this one out then, so because this is going to be 300 on the top, 28 on the bottom, so I divide the 300 by the 28, I would get 10.71 grams of hydrogen. So let's look at another mass problem. This is a mass volume, let's see. Okay, let's look at this problem. It says how many grams of potassium chloride are produced in 25 grams of potassium chlorate when it decomposes. Now this is one of those that's a decomposition reaction, so you might need a little help on what happens. So this is my potassium chlorate, and my ClO3 is my polyatomic ion for chlorate. It has a -1 charge, a +1 charge. I'm getting potassium chloride, and my other product would be oxygen. So you might need a little bit of help on getting that one written out. So the first thing I'm going to do is go ahead and balance my equation. So we'll run through that real quickly. This is one we've already done in the past, but we'll look at it just real quick. So I have 1 potassium, 1 chlorine, 3 oxygens, 2 over here, so I'd have to multiply this side by 2 to make it 6 oxygens, which affects the potassium and the chlorine since they're both connected to that oxygen. I have to multiply by this one by 3 to make it 6 oxygens. And then I have to come over here and multiply these by 2 so that my potassiums and chlorine balance out after we fix that. So now I would have a 2 here, a 2 here, and a 3 here. Once I get my balanced equation, it's asking me for how many grams of potassium chloride. So I'm going to change colors just to make it easier to see. So how many grams of potassium chloride, so we're looking for X grams, are produced if you have 25 grams of potassium chlorate decomposing. So I want to start off with what they give me. They give me 25 grams of potassium chlorate. The first thing I want to do, if it's a mass problem, is take the grams they give me, 2 moles of that same substance. So to do that, remember, you've got to find your gram formula mass. So for potassium, it's 39 times 1. For chlorine, it's 35.5, again, times 1. And for oxygen, it's going to be 16 times the 3, which would be the 48. So if you add your 39, your 35.5, and your 48, you're going to get 122.5. So that would be the gram formula mass. It's going to go on the bottom so that your grams unit can cancel out. And we know that that's equivalent to 1 mole because it's its gram formula mass. So basically what we did in the first step is convert our grams to moles. So take whatever you start with and get it into moles. The next thing we want to do is our mole ratio. What our mole ratio does is it allows us to go from the moles of what we started with to the moles of what we're looking for. So we have 2 moles of potassium chlorate. We'll put that on the bottom. We're going to 2 moles of potassium chloride. We're going to put that on the top. All this step does is allow us to go from moles of what we started with to moles of what we're looking for. In this case, if you skip this step, your numbers would end up being the same. You just wouldn't show how you went from one substance to the other because the mole ratio is a 1-to-1. And then finally, we want to go our moles to grams. So we have moles of potassium chloride. Here we want to go 1 mole of potassium chloride. Again, get its gram formula mass would go up here. So that would be 39 and 35.5, which would be 74.5. Moles would cancel. So looking at this, you can see that you started off with our grams. It goes to moles by using the gram formula mass of that compound. Grams of the initial substance cancel out, you'll be in moles of that substance. The second step is our mole ratio. So moles of what you started with versus to moles of what you're going to. You're getting these numbers. These 2's are coming from your balanced equation. This allows me to convert from potassium chlorate to potassium chloride, which is what I'm looking for. Once I get to moles of potassium chloride, I can get to grams of potassium chloride by using its gram formula mass. And now the rest is just plugging everything into your calculator. So you'd have your 25 divided by the 122.5 times 2 divided by 2. So you really wouldn't have to do that if you didn't see that. And then, of course, times the 74.5, and I'm getting 15.20 grams of potassium chloride.